Pleasure to be part of this event, and thanks a lot for all of you joining us to discuss about such an important topic in this such an important industry. Basically, we are going to discuss about the combined operation of the data centers for the purpose of the cooling and the energy traceability, basically, for the data centers. Those are the two important topics for the energy management of the data centers. And this has been a major and then sort of increasing elements in the operations of the increasing interest and the importance in the operations of the data centers these days. I mean, cooling and the waste management, the heat management from those data centers has been this sort of an important topic. And then, sorry for my voice, I got a cold. And then the energy traceability topic on how we make sure that the energy consumed by the data centers is coming from the source that is being claimed, and what are the carbon content of that kilowatt hour or megawatt hour of the consumed energy for the data center is being a sort of the major topic and the major importance in the industry, basically. So I will start to give you more discussions about this cooling angle, and then what do I mean from organic data centers and the combined operations. I will go to the energy traceability topics afterward, and then I assign a good amount of time for the Q&A section. So then is is open to everyone to ask questions, and then I'm happy to discuss about the different topics that they will come up in as a matter of this conversation, basically. I mean, we all know that the IT sector is accounts for 2% of the around that, and then is increasing a lot on the total carbon emissions. It seems to be a low number, but then if you compare it with the aviation and the movements that we have there, basically is the same amount. And then we see, for example, in the aviation sector, we are discussing about SAF, for example, sustainable aviation fuel, and a big movement there. And then we see on the IT sector that we have the some good movements as well, but then the size is the same as the aviation. And then it is the fact that it is increasing considerably. I think it makes it even more important when we discuss about the energy management for the data centers. I mean, the energy demand for that sector is increasing, is doubling every 9 to 24 months, basically. And then the size of the only data center consumption in the US is equivalent to the total consumption in Sweden, basically. It doesn't mean that Sweden has lower population. It means that it has a significant importance in the area that we are discussing about the energy management, and the fast pace of changes on those sort of industry when we are increasingly dependent on the data centers, and then having more data on the clouds and all the operations there. We see the high importance of addressing the energy waste management from those data centers, and then addressing the right ways to manage the energy from the data centers in the larger scales, basically. If you look at the actual heat waste that we see with data centers, we see in the seasonal way that there is a correlation between the demand for the other type of the heat consumptions that they might combine with the data center to make an organic way to make the waste heat to be used in a proper manner. I mean, in the summer, of course, there is a sort of lower heat that is coming, and then this can be used in the data center, and that correlation has made us to look at the combined solution between a data center and the greenhouses, where there is a possibility to take the waste from the greenhouse and then being used in from a data center and being used in a greenhouse, basically. There are 4 models that we have investigated, and we put the efforts to make that commercial in the real data centers, there is one is called the free cooling with return. When the heat waves coming from the ICT servers can go to the greenhouse, and then there will be a sort of a return of the cooling and then the fresh air coming inside the data centers. There is a sort of a way that the free cooling without the return, that is the only the heat from the data center is going through the sort of the greenhouse, and then there will be some sort of waste from the greenhouse that is coming out as well. And the last model that we have been looking at is the way we call it more air conditioning type, that there is no fresh air coming from the data inside the data centers, and the sort of the heat waves coming from the data centers goes to the greenhouse, and there is a sort of the output of some sort of waste from the greenhouse that is coming. Generally, it is increasing the efficiency, energy management of both the data centers and the greenhouses. These three models can be different and applied differently based on the location and the heat that is coming outside a data center and the sizing of the greenhouse as well. But this we see that has been a way to manage the heat from the excess heat from the data centers basically. I mean, we call it organic data centers, and then we believe that this will contribute to lower the carbon emissions on the operations of the data centers considerably. And that's the sort of the way that the food that is produced from those greenhouses can be labeled also in a way that they contribute to the carbon reductions, and then can be labeled in a way that make the customer awareness generally from that sector as well. And this we have seen a sort of some implementations of that in the mainland of the Europe, and then also some in Sweden and the Nordics as well. And then those type of implementations, of course, I mean, there are ways to manage the excess heat in much different ways. Injecting that to the district heatings, for example, that has been a solution. But those sort of innovative ways, they're more location based, and finding the right balance of the solution for that specific location of the data center and the greenhouse would contribute to the lower investments, basically, to manage the excess heat, reducing the carbon emissions, and bringing more operational efficiency for the both sides of the picture, both the sort of the data center and also going to the greenhouse as well. So that has been the sort of the way. I mean, considering the fact about the district heating, I mean, there are drawbacks connected to that. There are not always availability of district heating to inject the power from a data center to the district heating, and is not widely being used across Europe or the other countries. Of course, in the Nordic, in the big cities, we see the sort of the large infrastructure of the district heating, and there is a possibility to connect that. But then again, I mean, in the locations that we have district heating, the price of land is much higher, and then not properly, not a proper location for the bigger data centers, if there is a need for the larger sizes of the data centers to be implemented. And that's where we see the sort of the organic data centers that we are looking at, and we have developed the business models around that has been the sort of the solution to address the excess heat, and then make a sort of a combo investments when it comes to the packaging, the investment basically, or location in sort of a strategy for a data center or even a greenhouse basically. Moving forward from this exciting topic to the other angle, where we see the sort of excess heat to be a large percentage of the energy that is normally being wasted. Now we're going to understand that what is the sort of the energy traceability aspects connected to the data centers, and why this is gaining such an importance in the operations of the data centers going forward. I mean, energy traceability is generally a consumer right, because in any product that is being consumed, it is a right of the consumers to know the source, and then can properly make a decision on which product they are buying. I mean, we know all we know about the climate change and the effects that has been made on our lives. And then, of course, the third angle is about the carbon reporting, and then the eventual quality of the services providing from the data center going to the end consumers, basically. And if it is a co-location services or whatever sort of services, the operations of the data centers would influence on the eventual quality of the services provided by the data centers to the end consumers. And then, of course, it's not affecting on the PUE in many senses. I mean, PUE is affected by the way that we access it, but it's discussed. But then this energy traceability is an extra measure, making sure that there is a way to make the energy basically traceable and show the customers the exact sort of carbon content of the consumed energy for the data centers. The challenge here is like that we cannot tag electrodes. I mean, you can go to any for the clothing shop and then you buy the clothes that is properly labeled. Where does it come from, or what is the material that is being consumed for that? But then for electrodes moving through the sort of the whole power grid is hard to or I mean impossible generally to tag them basically, and that's why we develop. I mean, when I say we, basically those that are leading the industry or just setting the standards for that, not me specifically, but then the people involved on those developments, a sort of a book and claim system. I mean, we have the same challenge with olives, for example. It's hard to 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 label each olives, and then it goes to be a sort of an olive oil. And then also is the same challenge when there is a consumption for the energy inside a household or a data center. It's hard to label if this is coming from the solar panels or coming from the wind farm. And then the biggest issue is basically the trust or the compliance basically connected to that. How does it work? I mean, I mentioned about book and claim systems. Works for olives. The same works for the energy side as well. I mean, when there is a requirement to buy the X amount of the product that should be from sustainable sources, instead of buying all the products that is coming from the sustainable sources, you can buy the certificates that just labeling that sort of product that is coming from that is always connected to a physical product that is coming from that sort of system. But then also you can buy your product separately and buy the certificates connected to that, so that you verify the source with that sort of certificates that verifying the source. I mean, imagine here that we see that if there is a sustainable sources and then there is a need for the certificates. Eventually, we end up buying these 200 kilograms of sustainable and non-sustainable ones, but actually directly you might buy only 100 kilograms like directly from the sustainable source, and for the rest of them you buy the relevant certificates that is connected to a sort of a sustainable product basically that is being consumed. I know that this might feel a bit dodgy, or you might feel that is that sort of the right way to manage that, but this is the sort of the only way that we managed such a mass of the products, and then we try to understand the source of those products in olives, and then going the same for the energy basically. We have booking claims for the energy across the board, widely accepted, and it's named very differently in different countries, but then it's exactly the same or almost exactly the same system for the verifying the source of the energy. In North America is called REC, in Europe is called guarantee of origin. And then, I mean, we have IREC also is a widely accepted standards for that. If you go to China, we have a product in Australia, in Japan. So there is a big consensus across the industry that how we verify the source of the energy consumption with those book and claim systems. And then in Europe, starting from 2009, there has been an initiative called Guarantee of Origin that apart from verifying the source of apart from paying for the grid logistics and the retail, there is an extra cost that all of us on the end energy consumption that we pay is for the guarantee of origin, almost 10%. It can be up and down depending on the pricing of that, because it's basically a free market for that product, broker-based type of systems that's still not really sort of structured, and that's why we at Espritu will try to make that more structured as well. And then we verify the source of the energy with those guarantee of origin products, basically. If you might have heard a lot about the market-based and location-based carbon reporting, and then that connected to the data centers as well. I mean, market-based carbon reporting is connected to these renewable energy certificates, the certificates that I'm talking, or guarantee of origin in general that I'm mentioning here. And they are meant in the larger scale of the system to verify the source of the consumption and then making the balance, in the mass sort of market. But then the location base, you go to every single location and find the exact sort of the mix of the energy on that specific location. I mean, on the location base, you can contribute to lower carbon emissions by installing like the rooftop solar installations to reduce the carbon emission at that specific location. But then if we want to have a sort of a larger effects on the lowering the carbon emission and bringing the traceability and transparency to the market, we need to go to have a market-based mechanisms to lower the carbon emissions, and that's the systems that we have in place. Maybe you ask yourself, I mean, we can buy those offsets, for example, for the carbon emissions and for the reporting. Yes, that's very possible, basically, and it accounts for all the scope of the carbon emission, scope 1, 2, and 3. But there is a caveat connected to that. I think the carbon offset type of systems is very less mature if you compare it with the renewable energy certificate systems. I mean, they are not directly contributing to the lowering the carbon emissions from the source that is coming. So you have more compensating effects from the offsets and the way that the offsets work. But then from renewable energy certificates, they are connected to the actual generation of the energy from the renewable source or whatever source that they are coming. And then those sort of products are contributing to the more transparency of the energy systems and generally for the data centers as well. And that transparency and traceability will eventually contribute to lowering the carbon emissions, because with showing the customers the source and giving them the choice to choose the product that is they want to buy, we believe that we shift the sort of the markets to more lower carbon emissions and lower sort of more renewables basically as well. So, I mean, renewable energy certificates, they don't mean to directly decrease carbon emissions in the whole systems or for the data centers, but they are the sort of they indirectly contribute to that, and they are the sort of a policy mechanisms for the transparency and traceability. And then, as I mentioned, why they accepted across the board for such a important topic. I mean, not only for the data centers, which is a sort of increasing importance, but also it is gaining the momentum in all other industries basically connected to that. For the data centers, this topic is gaining the importance because of the competitive landscape of the services providing from co-location or whatever services eventually that is provided to the end consumers of the data center services. And that sort of competitive landscape requires to differentiate the product that you are providing. And one of the most important ways is like that you provide extra traceability and transparency on the source of the energy consumption. And that's the sort of the way that you would contribute to the environment, is getting to be a legal requirements also around that. And then also, I mean, it provides a sort of a differentiated product eventually to the end consumer. And this can be applied to larger sort of data centers, medium-sized data centers, and even smaller ones that they want to differentiate their product outside in the market, and the way that they would contribute to the lower carbon emissions in the board as well. So, I mean, there is an important element inside that movement of the renewable energy certificates, and is connected to the 24/7 carbon-free energy, where the sort of is a sort of a next step where you would try to understand the source of the energy consumption in hourly basis. Now the sort of the systems are more yearly basis or quarterly basis, that you aggregate the whole consumption and you go outside into the market and buy the relevant certificates for the aggregated consumption. And then this aggregated sort of certificates that is bought, it cannot match the actual consumption, because I mean there is no matching happening there. And then now the sort of the movement and the sort of the industry, there is a mention in the Renewable Energy Directive 3 that was published October last year. And then it was a mention of granularity for those type of certificates to increase the sort of the transparency of those systems. And that's why this is gaining momentum also from the regulatory side as well. And then those sort of hourly or granular type of energy certificates will contribute even more to the way that brings the transparency into the market. And as I mentioned, is a sort of next step after acquiring those certificates to make them even more transparent and traceable. And we have a sort of a legal obligations, for example, on the hydrogen generations, that this should be hourly basis. And then if there is a sort of a claim of green hydrogen, and this should be, there is a mention that in the data centers operations, I think if to differentiate the product and the services coming from that sort of data center, is it's important to have that basic element inside. And I mean, the benefits is basically contributing to effectively to lower the carbon emissions, the transparency, the right investments, that they are coming to the right locations. For example, if there is a more need for the wind in that specific location, when there is a sort of a constructions of the data centers, with having this hourly basis type of renewable energy certificates, will motivate the generation to go to the near to the consumption, and then promoting more sort of storage systems. And also this will reflect more about the economies of the power grid and how the sort of the overall power grid works, basically. There is a sort of, this is the price of the guarantee of origin. I mean, it has increased considerably during the last couple of years. And then the main driver has been, I mean, the increased demand for those products, but also the way that this, I mean, there are some effects from the general inflation increase across the Europe, but also it shows how the consumers are gaining the sort of the understanding of the importance of those renewable energy certificates these days, and the demand has been increased considerably during the last couple of years. I mean, this comes to Spiritu. What we do basically, we provide a B2B marketplace for those energy certificates, and then for the data centers specifically as well, that we reduce the energy certificate procurement cost by 20%, and we increase the granularity from a yearly product to an hourly product. So we call it 8,760 times is the number of hours that we increase the granularity to be compliant with the upcoming regulations. And then we're setting the standards basically also for the procurement of those energy certificates. And then we have developed an energy traceability machine is one of its kind, in which we try to match the consumption with the generation. We do very clear auditability services. We provide some tokenizations that can be connected to some blockchain systems, and it can be even connected to device level, basically. And with our partners, we have developed this energy traceability machine that is specifically adapted to the needs of the data centers and the evolution of the legal requirements around the energy consumption and the sort of the source verifications of those uh, energy consumptions in the data centers, and help our customers to procure those with lower cost, increase the quality of them, and make sure that there is a sort of a regular and easy way to trade, and then make sure that there is a right balance of those energy certificates all the time that you buy that. This can be a sort of a weekly process or monthly process that, I mean, these certificates are being bought, and then to be connected to the sustainability reporting and the way that this will be reflected to the end way of providing that service from the data centers going forward. So I think that this comes to the point that I'm opening the scene to further questions, and then I'm happy to dig a bit deeper to the questions. But thanks for listening, and I'm happy to answer to the relevant questions and then discuss about the topics that gain a bit of thinking in the minds of the audience.
Thanks so much, Adam. That was great. I've got a couple of questions from the audience, if I may. I'll just start with the first. Considering the limited use of district heating systems outside of the Nordic countries, what are the main barriers to adopting these systems in other regions, particularly in relation to integrating them with data center operations?
Yeah, I think that injecting the wasted heat or excess heat from the data centers to the district heating, I think there has been the solutions across the Nordic when there is a sort of a presence of the district heating. And then, I mean, there should be very close, and there is a cost of connection. But of course, if the location is perfect and there is a sort of element of cost that it can be justified in that such a connection, is one of the most cost-effective ways to do that, because of the ways that even the utilities, those district heating operators, they would love to have such an excess heat, and they pay well also for those excess heat to be injected to their sort of systems. But as you mentioned, they are not always sort of located next to a data centers. As I mentioned before, I mean, the locations that we have a district heating, maybe the price of land, it can be a bit of expensive for large implementations of the data centers. I mean, with the solution that we discussed about the greenhouses, I mean, the organic data centers, basically, it gives a lot of flexibility when there is a sort of in an investment phase or finding the right locations where sort of these two sort of location can add value on the energy management to each other, and the way that they are bringing the operational efficiency on their energy side together as well. I mean, it's hard to envisage that the investment comes on the same package, basically, but then when there is a sort of a locationing discussions and finding the right sort of land or in the project development phases of a data center, this gains importance. And then we see more developments in the mainland of the Europe than for example, in the Nordics for this type of solutions where I mean, there is less district heating, and that sort of solution connecting to a greenhouse would gain the sort of the importance, basically.
Thank you, Adam. And how does energy traceability impact the strategies for cooling in data centers with regards to optimizing energy use and reducing the carbon footprint associated with cooling operations?
Yeah, energy traceability is just labeling the whole electricity consumption that is inputting the whole data centers. So then that's affecting basically on the whole energy consumption for a data center. If there is an excess heat that is coming out, basically that affects on the sort of the PUE of the data centers to bring more efficiency for the operation of that. But energy traceability is an element for all the sort of the consumption of the data center, and is affecting it. Either is an excess heat, basically, that can be recovered, or the general consumption of the data centers that needs to be traceable. And there is a sort of, I mean, we have CSRD, that's the Corporate Sustainability Reporting Directive that has been sort of being implemented, and many that they are trying to find the gaps in their reporting system, and that's the sort of the gaining the importance that you would need to have the right sort of ways to trace your energy and the way that you report your carbon emissions as well. And this goes to whatever sort of energy consumption. Is it for the actual data center, or this will be an excess heat that requires cooling or whatever? So yeah, that's for all basically. Yeah.
Thank you. From the perspective of energy traceability and sustainability, could you discuss the feasibility and potential benefits or challenges of data centers installing their own renewable energy sources and storage systems compared to purchasing green energy from the grid?
Yeah, that connects to the discussions that I had about the location-based and market-based solutions. I mean, investing on a type of renewable generation assets connected to the data centers is very sort of great initiative, but it doesn't affect on the market-based solution. In the location-based solution, you try to reduce the carbon emissions on that sort of specific location. But then for the whole energy consumption for your data center, you're required to buy those renewable energy certificates if you want to claim those are the sort of the green energy that is being consumed by that data center. Is either that you use your certificates from your wind farm or solar park that you install next to the data center to be used in that specific data center, and then you might need to buy extra of that to show the source of the consumption for your data center, basically. But I think investing on the renewable assets next to the data center is highly appreciated, is contributing to the lowering the location-based carbon emissions in that specific location. But then the general rule is that for the market-based solution, you need to buy those renewable energy certificates for the whole of your consumption, either coming from the external sources that are being purchased, or there's a sort of your solar or wind farm that they generate certificates as well that they can be cancelled or assigned to your consumption in your data center.
Thank you, Adam. And just if I could just squeeze in one more question before we move on to our next session. Do the energy certificates refer to energy directly connected to the same grid as the data center?
Sorry, can you answer?
Sorry, yeah. Do the energy certificates refer to energy directly connected to the same grid as the data center?
Yeah, I think that we have in the operations of the electricity market, we have three levels of the markets. I mean, we have a physical market operated by large energy companies and TSOs, the transmission system operators. We have a sort of a wholesale or retail market, basically, and then we have a third level in the certificate market. They are decoupled right now from each other. So then they have a sort of a separate operations. There are research that is being done on how these three levels can be coupled to each other. I think it's a bit of long shot to think about that. The reasons, is clearly that, the movement that I mentioned to you about 24/7, the sort of the hourly renewable energy certificates will contribute to bring those three levels together and have a bit coupling of those three levels. But currently, the book and claim systems that we have in place for renewable energy certificates They are connected to the generation and the consumption data for sure, but they are not coupled to the retail or wholesale market or the physical grid operations, basically.
Okay.
So there is a bit of decoupling there, but yeah, I think on the research board, this is being developed. But then the sort of the cutting edge technology and the systems that we have in place right now, they are operated a bit decoupled from each other. Yeah.